Okay, we have here today another interesting integral from the MIT Integration Bee from 2024. This one's problem 15. We have the integral of x plus 1 minus e to the minus x times e to the x dx. Now my first thought in this one is there has to be a relationship somehow between this and this, that there may be, if we take the derivative of this, we get this or something close to this. Well, I was messing with it and it didn't really work that way. I couldn't just make, what I wanted to do is make a u substitution for this. And it does seem like there's a relationship between this and the derivative of this. But the real problem in this I was thinking about was we have e to the minus x in here. And when you take a derivative and you have, not only is the exponent on this e positive, but then this is positive as well. So my thinking was we're never going to get a negative exponent here if we have a positive exponent over here. So what I decided to do is try to fix that, or at least fix this term anyway. And what I can do is, what I want to do is multiply in by e to the x, because then because if I multiply in here by e to the x, this is going to just become 1, but I don't want to change it, so I'm going to multiply by e to the x over e to the x, so I'm just multiplying by 1. So when I do this, I'll rewrite it and I'll distribute this 1 in the numerator into the parentheses. So this is going to become x e to the x, then e to the x times 1 will just get plus e to the x. And again, right here, e to the minus x times e to the x, you get e to the 0, or just 1. And then here I'll divide this one into this ex to the e. I'll divide this here into this. We've got the same base e, so I can write this as e to the x e to the x minus x. And now we notice we've got no negative exponents over here like we had here. But I'm thinking now if I do a u substitution here, making my u substitution for this, maybe this is going to work well with this. So let's just see what happens when I do this. We'll try it out. So we'll set our u equal to this thing, ex e to the x minus x. And then carefully take a derivative. It's just a little complicated. So first, again, this is all in the exponent. So the first part is I just get the whole thing back, ex e to the x minus x. But then we need chain rule taking the derivative of this thing. And so on the first part, we're going to need product rule. So we take a derivative of the x, we're going to have 1, and then we just keep the first part, we keep the second part, e to the x, plus we'll keep the x and take the derivative of the second part, e to the x. And then we'll just take the derivative of minus x, that's just going to be minus 1. And then we'll sneak in a dx. But then notice what happened is this right here is the same thing as this. This right here didn't change. This is what we had for our u. So actually the whole integral, including the dx, this all becomes just du. So of course there's not really much to do because when the integral is du, we just get back u. But let's just write it out formally. So we're integrating du, and so we're going to get u plus c. But we'll just back substitute to finish it. So our solution for this is going to be just ex e to the x minus x plus c, and that's it. Okay, so pretty interesting. It seemed complicated at first, but with this one trick, we find this whole thing is just the derivative of this thing over here. That's it for today. Thanks everyone for watching. Have a good day.